Hello everyone. Topic for today is rectifiers. Rectifiers in which we use our diodes. We have discussed in the last classes what is a diode, a p-side. When a p-type and n-type semiconductor is joined, then a diode is formed. Now this is your p-n diode. It will conduct, if we take an ideal diode, that will conduct during forward biasing and that will not conduct at all during reverse biasing. So it is acting like a switch. During forward biasing, like when it is on, it will conduct. During reverse biasing, it is off, so it will not conduct. Now how to use this in rectifiers? What are rectifiers actually? Rectifiers are the devices which converts alternating voltage or current, like of this form, into direct voltage or current. Direct voltage or current means you can say unidirectional. For example, if this is the input, it is given to a device and then you are getting an output of this form. That is pulsating unidirectional current, or you can say it is pulsating DC also. So this type of device, this is called half wave rectifier. This is your half wave rectifier because they convert only half of wave of the AC, full wave. This is the full wave, so it is just converting half of the wave into the DC. When you are having this one and the output is like this, this is called full wave rectifiers because they are converting the full wave. Okay, they are converting the full wave into the DC. Still it is having some AC component like this one. This is the AC component that is further filtered through the filter circuits that contains your inductor and capacitor only. So that is not in your syllabus. You have to discuss rectifiers only, half wave rectifier and full wave rectifier. Now let us see how this waveform is obtained from half wave rectifier using this. Now first we will discuss half wave rectifier. Half wave rectifiers. Now this is the circuit diagram for half wave rectifier. There is a transformer, step down transformer. So this is the primary coil with more number of turns. This is the secondary coil with less number of turns. This is to step down the voltage. Here we apply our AC voltage, whatever voltage you want to apply here. And here in this part with the transformer, a diode is connected, a single diode is connected, and the output is obtained across this load resistance, say RL. So here we obtain the output. Now how does it work? See, during positive half cycle, like when we are giving it the AC, suppose during positive half cycle, this end of the diode, P end of the diode, this is getting positive from this and this end is getting negative. So this diode is in forward biasing. When it is in forward biasing means it will conduct, so it will give you output like the same because in forward biasing it is having least resistance. So whatever current it is getting from here, if the current is increasing, here also the current is increasing. If the current is decreasing, see how is it happening? Like if it increases, it also increases. If it decreases, it is also decreasing. So it is giving you the same output as it is having in the input. Now what happened during negative half cycle? During negative half cycle, the polarity get reversed. The upper end become negative and the lower end become positive. This end become positive, so positive is given from this side. Now your diode is in reverse biasing, means it will not conduct. For this half, there will be no output, means it is blank. Because this is in reverse biasing, so it will not conduct at all, so there is no output. Again, for the next positive half cycle, this is again positive and this is again negative. Now your diode is in forward biasing. Now forget this. Now this is during next half cycle, this is positive, this is negative. So this diode is in forward biasing. Again it will conduct. So if current increases, here also current increases. If current decreases, here also current decreases. Okay, so these are the things. Again for the next negative half cycle, it will not conduct. So the output is like missing DC somewhere. It is called pulsating DC. So for half wave rectifier, this is the output. Once again, what is the working of half wave rectifier? We have connected a single diode with a transformer. This is step down transformer. This is primary coil. This is secondary coil. So when positive half cycle is applied, let us consider at this time this upper end become positive, the lower end become negative. So positive is connected to P side, negative is connected to N side, means this diode is in forward biasing. Now when it is in forward biasing means it will conduct, so we are getting the output same as our input. But during negative half cycle, the upper end become negative and the lower end become positive. So upper end negative means negative is connected to P side, and lower end positive means through this it is connected to N side. So it is in reverse biasing. So in reverse biasing it will not conduct at all, means there is no output. So these are the things. So here is the output for half wave rectifier. Now how it has been modified in the full wave rectifier. Now what is the working of full wave rectifier? So for full wave rectifiers, you see this one again, a step down transformer. This is the circuit diagram. A step down transformer is there. Now there are two diodes instead of one. This is say diode D1, this is diode D2, and the output is obtained across this load resistance in the center. So here you are obtaining the output. Now in diode the direction of current is from P to N, means arrow side. This is the direction of current. Whenever they will conduct, this will be the direction of current. Now in this case, when the positive half cycle is applied, positive half cycle of AC is there. Suppose the upper end is positive, lower end is negative. Now here positive is connected to P side, means this diode is in forward biasing, and negative is connected to P side, means this diode is in reverse biasing. Thus this diode will not conduct, only this diode will conduct, and due to this current will come like this. Current through the load resistors will be from, say if this is AB, it is from B to A. So whatever like current is increasing, in the output the current is also increasing. If it is decreasing, it is also decreasing for the positive half cycle. Now see here for the negative half cycle. Now this half cycle, this is first half cycle, this is negative half cycle. Now for this negative half cycle, suppose the upper end become negative and the lower end become positive. Now when the upper end become negative, it means this diode is in reverse biasing, because negative is connected to P side, and the lower end is positive, means D2. So this diode is in forward biasing. This is in reverse biasing, this is in forward biasing. Now this will not conduct, this will conduct. And what is the direction of current? See here, from P to N it is going like this, and then it is going from B to A. So this is the direction of current from B to A. Again means it is same as the previous case. Pehle bhi A, B to A, now also it is from B to A. Means even for the negative half cycle your output is in same direction. Clear? Like this diode will conduct, but direction of current is same. So that is why earlier it was in upward direction, now also it is in upward direction, although here it is in downward direction. Again for this half cycle, this diode is in forward biasing, means first case D1 was in forward biasing, so this current was due to D1. In this case D2 is in forward biasing, so this current is due to D2. Again it will be due to D1, again it will be due to D2. So this type of output is obtained. This is called full wave rectification, because full wave has been rectified. So still the waves are having certain components of DC, like this one. When the wave is like this component, this is still some AC present in DC. Okay, so this component is removed with the use of filter circuits. Filter circuits actually they contain an inductor and a capacitor in them. So they are made up of inductor and capacitor. You know, a capacitor blocks DC. It will not let DC to pass through it, but it will let all the AC to pass through it. So AC will be filtered out of DC. So like these filter circuits are used to further rectify this. Okay, this is the working of rectifiers, half wave rectifier and full wave rectifier.